So, what if you had a crystal ball? Not for telling the future, but for seeing the present with just unbelievable clarity. Well, today we are going to talk about a statistical concept that is basically that. It lets us understand millions of people just by looking at a tiny handful. Let's dive in.
And welcome everyone to the Tao Statistics Salon. This is the place where we make the numbers make sense and find those beautiful, elegant patterns hidden in the data that's all around us. Okay, let's kick things off with a huge problem, one that pretty much every single business on the planet faces. How in the world do you figure out what a massive group of people wants, your customers, your users, an entire market, when you can't possibly talk to every single one?
I mean, that's the real challenge, right? Imagine you're about to launch a brand new product. Are you really going to survey millions of potential buyers? Of course not. You don't have the time, you don't have the money. So, is there a smarter way, a faster, cheaper way to get an answer you can actually trust? Oh, you bet there is. This is where statistics hands us a genuine superpower.
And that superpower has a name. It's called the central limit theorem. And honestly, it is the closest thing we have to a real statistical crystal ball. It is the secret sauce behind everything from political polls to making sure the phone in your pocket was built correctly.
So what is this thing? What's the magic? Well, the theorem says that if you grab enough random samples from any group of things, and it doesn't matter what that group looks like, it could be totally weird and lopsided, the averages of those samples will always form a perfect, predictable bell curve. And that bell curve is the key. It tells us something incredibly profound about the entire population.
And that's exactly why it feels like a crystal ball. It lets us make these amazingly accurate, educated guesses about the whole population, even when that population is a total black box to us. We don't need all the data. We just need a small, well-chosen slice of it.
Okay, so how does this magic actually work? It sounds really complex, but the rules that make it all happen are actually surprisingly simple. They're kind of elegant, really.
Now, the key phrase you'll always hear is sufficiently large samples. That's the trigger. That's what unlocks this whole predictive power. So, you got to be asking, what's the magic number? How big does our sample have to be before this crystal ball starts to work its magic? 30. You're not going to believe it, but in most cases, the number is just 30. A sample size of 30 or more is usually considered large enough. It's wild, right? With just 30 data points, this beautiful, reliable bell curve starts to appear out of the noise. And that makes our lives as analysts so much easier. And just look at the relationship here. On one side, you've got the entire population. It can be shaped like anything, completely chaotic. But on the other side, look at that distribution of the averages from our small samples. Because of the theorem, it snaps into that perfect, normal bell curve. And even better, its center is sitting right on the true average of the whole population. And it's all governed by these two simple rules. First, the average of all our little sample averages, well, it's the same as the true population average. That's just common sense. But the second rule, and this is the really important one, the spread of those sample averages, we call it the standard error, it gets smaller and tighter as our sample size gets bigger. In other words, the more people you ask, the more precise your estimate gets.
All right, that's enough theory. Let's get our hands dirty and see how you can actually use this to answer a question. We're going to walk through a quick, real-world calculation right now.
Okay, imagine we know the average score on some big national test is 100, and the standard deviation is 15. Now, we take our own little sample of 36 students, and their average score comes out to 105. So the question is, what's the probability of getting a sample average of 105 or even less?
We can figure this out in 4 easy steps. First, we've got our data. Check. Next, we'll calculate that standard error. Then, we find something called a z-score. Now just think of a z-score as a universal ruler. It tells us exactly how unusual our sample is compared to the average. And finally, we just use that z-score to look up the probability. Simple as that. So here's the math for that z-score. We take our sample's average, 105, and subtract the population's average, 100. Then we just divide that by the standard error. We plug in the numbers, and boom, we get a z-score of exactly 2. So what does that mean? It means our sample's average is 2 standard units higher than the overall population's average.
And a z-score of 2 lines up perfectly with a probability of 97.72%. So the answer to our question is that there's a 97.72% chance of grabbing a random sample of students and getting an average score of 105 or less. See? We just used a tiny sample to make a really confident statement.
Okay, that's the math. And it's cool. But let's talk about the real magic, which is turning this into your business superpower. How does this actually help you make smarter decisions in the real world?
Well, it really all comes down to these three incredibly powerful ideas. First, you get predictability from what looks like total randomness. Second, you get the statistical confidence to talk about an entire population based on just a small piece of it. And third, you get the power of knowing that good enough data, often just a sample of 30, is all you need to start making some really solid predictions.
So think about market research. Instead of spending a fortune trying to survey millions, you can just poll a few hundred, or maybe 1,000 people. The central limit theorem is what gives you the power to say with a known margin of error that 65% of all our potential customers prefer this new feature.
Or what about quality control? A car company can't crash test every single car that comes off the line, right? Of course not. But by testing a sample of, say, 50 cars, they can get a very, very precise estimate of the average safety performance for the entire production run.
And this is absolutely huge in the digital world today. When a company runs an A/B test on 2 different versions of their website, they're only showing each version to a small sample of all their users. It's the central limit theorem that lets them confidently say, version B is the winner and it will perform better for all our users. That confidence is everything when one tiny design change could be worth millions of dollars.
When you get right down to it, this theorem is a bridge. It connects the data you actually have from your small, manageable sample to the insights you desperately need about the vast, unknown population. It really is the foundation for making smart, data-driven business decisions.
So there you have it, the central limit theorem. It's a simple idea, but it is so profound, and it lets us find certainty even when things look uncertain. So now that you have the key to this statistical crystal ball, what are you going to predict first?